Okay, this is lesson 3.6, video number 5. Prove that our sequence x of n is equal to sine of 1 over n, where n is 1, 2, and it goes on through infinity, is a Cauchy sequence. Prove x of n is a Cauchy sequence for all epsilon greater than 0 there exists an n, which is an element of positive integers. Choose n. We don't know what n is. We gotta find that. We're gonna go through our scratch work for that, where n and m are elements of the natural number set, and lowercase n is greater than our number uppercase n, and m lowercase m is greater than our uppercase n, and where the absolute value of the difference between x sub n minus x sub m is less than epsilon. Okay, so first thing we're going to do is we're going to put in our sine of 1 over n minus sine of 1 over m, and that's all in the absolute value is less than epsilon. So we're putting our sequence into our absolute value less than epsilon. So using the triangle theorem, we want to first we're going to make that a plus, so that's going to be sine for 1 over n plus a negative sine for 1 over m, and so we know that's less than epsilon. Okay, so now we can split this using the triangle theorem. We can say that this is less than, when we split it, sine 1 over n plus the absolute value of negative sine 1 over m. And since this is absolute value, all that can go away, so that sine, the negative can go away, 1 over n plus sine 1 over m. Okay, and then from here, the absolute value, we can eliminate the negative, and so with okay, now let's evaluate this for a moment. And since the absolute value of sine of, for example, pi over 6 is less than just pi over 6, we can because the sine of pi over 6 is 1/2, right? Whereas pi over 6 is, so that's 0.5, whereas just pi over 6 is 0.56, something irrational number, so it's larger than just 0.5. So therefore, the absolute value of sine, then we can say that the absolute value of sine 1 over n is less than 1 over n, the absolute value of 1 over n. And if that's true for n, then that's going to be true for m as well. So we can say that this is less than the absolute value of 1 over n plus the absolute value of, since the sine of 1 over m is going to be less than the absolute value of 1 over m, then we can put that in there. And all that is less than, so we're saying here that since this is absolute value, it's positive, we can drop the absolute value, so that's 1 over n plus 1 over m, and since all that is less than epsilon, then we can make the note that 1 over n plus 1 over m is, so let's examine 1 over n. Since 1 over n plus 1 over m is less than epsilon, then 1 over n is less than epsilon over 2. Since these two together are less than epsilon, then we can say, alright, then 1 over n is less than epsilon over 2. So we're going to split this. So we have an epsilon over 2 and epsilon over 2. And so if we flip this and switch the inequality sign, then that'll be n is greater than 2 over epsilon. Well, we said before that n is greater than uppercase number n. So then that means that n is greater than uppercase n, and so that's going to be greater than 2 over epsilon. So we can use this back here and right here. So we can say n in our proof is greater than 2 over epsilon, and then from there we can go back and do our proof. We're going to go back and do all these steps, and so when we get to 1 over n plus 1 over m, then we can say that this, so from there we can say that this is less than 1 over uppercase n plus 1 over uppercase n, since we said before that n is greater than uppercase n. Since we said this once before, then the denominator is going to be larger than n, than if we were to say 1 over n. So that makes the fraction smaller. So that makes this expression smaller than this. And since we said that n is greater than 2 over epsilon, then this will be 1 over 2 over epsilon, and then 1 over 2 over epsilon. And so you flip that, you apply the reciprocal, and you get epsilon over 2 plus epsilon over 2 is equal to epsilon, and you've proven it. So that concludes this video.